Okay, back with number 10. The numerator is x squared plus x plus 1, and there are no factors of 1 that add to equal 1, so that numerator does not factor. Okay, then denominator is linear, x plus 1, so there are no wholes since there are no canceled factors. Okay, then to find equation of the vertical asymptote, we set the denominator equal to 0. So x plus 1 equals 0. Subtract 1 from each side, and x equals -1 is going to be the vertical asymptote. And so we can sketch that on our graph. Okay, then the coordinates of the zeros, we would take the numerator x squared plus x plus 1 and set that equal to 0. Okay, and since that's not irrational, since that is not going to factor, we're going to need the quadratic formula to find any irrational or imaginary zeros. So a is equal to 1, b is equal to 1, c is equal to 1, and x equals -b plus or minus the square root of b squared minus 4ac. So that's going to be 1 minus 4 is a -3. And that's all over 2 times a, which is 2. And since this is a negative under the square root, we know that these are imaginary zeros. And so there are no real zeros. And we would want only coordinates of real zeros to see if they would appear on the graph. So this has no holes and no real zeros. Okay, to look for a y-intercept, we put 0 in for x. So 0 squared plus 0 plus 1 divided by 0 plus 1 is 1 divided by 1, which is 1. So 0, 1 would be the y-intercept, and we can plot that with a closed circle on the graph. Okay, then equation of horizontal or oblique asymptote. So Bobo Botan eats DC. We know bigger on top, none. And since this is a 2 over 1, right, that would be a bigger degree on the top. So there is no horizontal asymptote. Instead, there's going to be an oblique asymptote. And that oblique asymptote we find with division. So since the divisor is x plus 1, we'll use a -1 out front. Then our coefficients, 1x squared, 1x, and the constant is 1. We bring down the first value. 1 times -1 is -1. Then we add 0 plus -1 is 0. Multiply 0 times -1 is 0. Add 1 plus 0 is 1. That's the remainder, the constant, and the x of the quotient. We discard the remainder. The constant is 0, and so our oblique asymptote is y equals x. And that's a diagonal line through the origin. So we start at 0, 0, and we have a slope of 1. And so there's the dashed line for the oblique asymptote in number 10. Now to find an extra guide point, it says -2 comma blank is a relative max. So we're going to put -2 in here for the x's. So that's a -2 quantity squared plus -2 plus 1, all divided by -2 plus 1. So we have a 4 minus 2 plus 1 is a -1, and then -2 plus 1 is -1, and that's then -3. So -2, -3 and it tells us that that point that we just sketched is a relative maximum. So our curve has to stay inside these asymptotes and then turn at that relative max and come back down along that vertical asymptote. And so then this one is going to do the same thing. Follow that vertical asymptote, turn, and then come along that oblique asymptote. So now the domain, we have a break in the graph here with an infinite discontinuity at -1. So we're going to be going from negative infinity to -1, union -1 to infinity. Now the range, the oblique asymptote shapes this hyperbola to have a big gap in between the relative extrema. So we're starting at negative infinity and then coming up and stopping at -3, and that -3 is an extrema. It's a relative maximum, so it's inclusive. So we get a bracket on that -3. Then there's nothing happening in between here until we reach this relative minimum where the y is equal to 1, and that is a bracket because the 1 is inclusive, and then we head up to positive infinity in the y direction.